Phosphine found in a brown dwarf for the first time. New observations measure the nickel to iron ratio of 3I Atlas. More evidence for Betelgeuse's companion, and Starship's Flight 11 goes according to plan. All this and more in this week's Space Bites. Phosphine has caused quite the stir recently. This is, of course, a compound that is found here on Earth as the result of the outgassing from bacteria, that it is a potential biosignature. It has come into the news because astronomers claim that they have detected the presence of phosphine in the atmosphere of Venus, and it does not seem like a very habitable place. And yet, at high altitudes, you've got water in the atmosphere, the temperatures are more reasonable, and theoretically, you could have some kind of airborne bacteria that is replicating and producing phosphine as one of its byproducts. Now, phosphine doesn't have to be formed by life. We know that there is phosphine in the atmospheres of the gas giants here in the solar system. It's been found in large quantities in both Jupiter and Saturn. And now, astronomers have found it in the atmosphere of a brown dwarf for the first time. And of course, the observation was made with the James Webb Space Telescope. Phosphine is easier to detect when the temperature is cooler. In other words, it was easier to see in the cloud tops of Jupiter and Saturn, and this is why it hasn't been detected in a brown dwarf until now. But brown dwarfs are really just very massive gas giants, not quite stars. And so when astronomers looked at a brown dwarf called Wolf 1130c, they detected the clear absorption signature of phosphine at 4.3 micrometers. And this is exactly where phosphine is expected to see. Now, observing phosphine is a very difficult detection because it has the same absorption line as carbon dioxide. But James Webb has the power to make these kinds of observations. And it's really interesting because this gives us a chance to observe phosphine in not an exoplanet, but a brown dwarf, which is kind of like a super exoplanet. And from there, we should be able to develop these techniques to be able to observe phosphine in smaller and smaller planets. And maybe one day we can observe phosphine in the atmosphere of an Earth-sized world orbiting around a sun-like star. And maybe that will be a true biosignature. If you want more information, there's a great story by Andy Thomaswick on Universe Today. One of the ongoing mysteries of Comet 3I Atlas is, where is all the iron? And this is a strange thing that you would be waiting to hear about for a comet or an interstellar object. But actually, iron and nickel are elements that are seen in comets that come from the solar system and also in interstellar objects. The last time we saw an interstellar object was with Comet 2I Borisov. And in that comet, astronomers were able to measure the ratio of nickel to iron. And those ratios match roughly what we see in comets that come from the solar system. So it's kind of surprising that Borisov was so similar to comets in the solar system. And comets have ratios of those metals, which is about 10 times higher than the sun, which is one of the mysteries, is how you can get that higher ratio of nickel and iron compared to other gases in these comets. And so as soon as Comet 3I Atlas was discovered, astronomers were watching for that signature of the iron. Now, the signature for nickel showed up earlier. And then when the comet got within 2.64 astronomical units of the sun, the signature for the iron finally showed up. And so what's going on here? It's believed that the nickel and iron are tied up with complex carbon molecules. So you get nickel tetracarbonyl for the nickel, and you get iron pentacarbonyl, and that those two molecules have a different temperature at which they sublimate off of the surface of the comet. And so we got the nickel first, and then as the comet continued to warm up, then we got the iron. And now you can compute the ratios of the nickel to the iron. But we're still at the very beginnings of making these observations, and the comet hasn't fully heated up. And so we're waiting for it to get to its closest point to the sun, to pass the sun, and continue to make those observations until we can no longer make them. And then after that final accounting, astronomers will be able to calculate the ratios of nickel and iron in the comet and then compare that to the comets we see in the solar system. And again, this is always really valuable because that gives us insights into the formation process and the chemical constituents of its home star system. And if it truly does come from the thick disk, if it is billions of years older than our sun, then it should have different ratios of metal compared to what we find here in the solar system. And we've got a story about this by Andy Thomaswick. Betelgeuse is a variable star, and it has 2 cycles. The one level of variation is very easy to explain. The star pulsates, and we can measure this straightforward pulsation on a regular basis. But it has a second, much longer variation that takes about 6 years. And astronomers have always wondered, what is the cause of this oscillation? One interesting theory is that there is a companion star that is orbiting just outside the surface of Betelgeuse. And earlier this year, we actually got visual evidence of that. Pictures were taken of this companion star, which has been nicknamed Betelbuddy by the Gemini South Telescope. And the observations had to be done at a very special time on December 6th. This is when the companion star would be at its greatest distance away from the disk of Betelgeuse. Other times it would be in front of it, other times it would be behind it, but on December 6th, it would be on the side of it from our perspective. And so astronomers made those observations with Gemini Telescope and see a hint of it. And at the same time, astronomers used the Hubble Space Telescope and the Chandra X-ray Observatory to also look for this companion object. They used Chandra because it's an X-ray observatory, and that if there's a white dwarf or a neutron star as a companion around Betelgeuse, then you would see evidence of accretion, that there would be material streaming off Betelgeuse and being accreted onto this companion object. And they didn't see this accretion, but they did detect presence of this companion star. And so now this is a bit of a mystery because Betelgeuse is 16 to 17 times the mass of the sun, while the companion star is about the mass of the sun. And this is not the kind of thing that you would expect to see. Normally you expect to see binary stars to be roughly similar in mass, but to have one that is 17 times the mass of the sun and then one that is 1 times the mass of the sun, that is very unusual and requires more observations and more theories. We've got a story about this by Mark Thompson. This week, we saw the 11th flight of the SpaceX Starship and Super Heavy booster. And I can report that the mission was kind of boring, and boring in the good way, in that nothing really unforeseen happened. Everything went roughly according to plan, and it was fascinating to watch and wraps up the end of an era with SpaceX Starship. This was always planned to be the last flight of the second generation of Starships, the V2 Raptor engines and the Super Heavy booster, as well as the previous generation of its launch pad. And so for Flight 11, they pushed the spacecraft to some of its engineering limits. They reused the same Super Heavy booster that was used on the 8th flight and did a couple of additional tests. The rocket lifted off, and you're always looking for the condition of all of the engines. And all of the engines were on all the way up until it made its separation. Starship separated, flew off onto its suborbital trajectory, and then we got just this incredible view of the hot stage ring as it was drifting back beside the Super Heavy booster. Just absolutely incredible. And like, it looked like it was moving in slow motion. And that was just because there's so little wind resistance. It was really high up when this was happening, and they had the same rough momentum. And then Super Heavy fired its engines, re-entered the atmosphere, and then landed off of the coast. And they demonstrated that it would be able to be caught, but they still landed it in the ocean. And then Starship continued on into orbit, didn't explode. That was great. And then released a bunch of dummy Starlinks, which followed the same suborbital pathway as Starship itself and would burn up in the atmosphere. And then it re-entered the atmosphere. We saw that familiar glow as it was entering the atmosphere. The connection to the Starlink network was great. We were watching for the heat damage as the hot gases find their way and start to tear apart the very delicate structures, especially in the various flaps. And everything seemed to be fine. I'm sure the engineers are going to be tearing it apart and finding out exactly what happened. It looks like the various upgrades and improvements have made its ability to withstand the heat of re-entry to be much better. And then it landed with pinpoint accuracy in the Indian Ocean. We saw an image from a buoy in the water, and then we got some drone shots of it as it was making its final landing. We can actually compare that to the previous landing with 10. It landed and then dropped into the ocean and is now sitting at the bottom of the sea. And so this is the final flight of the second generation of Starships. And so now we're going to move on to the third generation of Starship and Super Heavy, which is going to involve a more powerful Raptor V3 engine. We're going to see a new launch pad as well as other improvements and tweaks. And of course, the goal here is to capture Starship in the same way that the Super Heavy booster has been captured. This is a more difficult catch because it is coming all the way back from orbit. And this will enable the rapid reusability. So they will be able to refuel these in space and hopefully be able to send a version of this to the moon to serve as the lander for the upcoming Artemis 3 mission. And we've got more information about this from Alan Boyle. When NASA's Phoenix lander arrived on Mars in 2008, as its thrusters were decelerating the spacecraft to land near the North Pole of Mars, it cleared away the regolith and revealed water ice. And then the lander was able to dig into the ice, into the regolith, and tell us a lot more about the conditions of this upper layer of the material on Mars. And then other orbiting spacecraft have told us even more about how much water ice there is on the surface of Mars. We know that if you were to melt all of this water ice, you could cover Mars in an ocean about 1.5 meters deep. And an interesting idea has been that you've got these pockets of potentially liquid water underneath glaciers on Mars. They would be transparent, and so sunlight could be going through the ice and illuminating this material. This could be a place for life, kept safe under the ice on Mars. And so there could be life on Mars, and these would be the perfect places to look. But even if there isn't life on Mars today, there could be life that's hibernating on Mars. Researchers attempted to simulate the conditions of being under the ice on Mars. They took a strain of E. coli bacteria, put it into a capsule, and then embedded it inside of ice, and then bombarded it with cosmic radiation, equivalent to 20 million years of cosmic ray exposure. And they calculated that the E. coli could actually remain safe and hibernate for about 50 million years in the ice on Mars. And so this is the perfect place to go and search for life on Mars. Go to the North Pole, dig into this regolith, into the ice, do a core sample, and see if you can detect the presence of hibernating bacteria. Of course, the ideal would be to collect a sample and bring it back home to Earth. So we've got a really interesting story about this idea from Evan Goff. Every week, we do a vote on our channel where you tell us what you thought was the best space news story of the week. And because we didn't do an episode of Space Bites last week, we've got the votes for 2 weeks to report. So first, 2 weeks ago, Space Bites, the winner was the launch date for Artemis 2. And then for the Comet 3i Atlas episode that we did last week, the winner was the potential age of 3i Atlas of being over 7 billion years old. So thank you everybody who voted for the last 2 weeks. Now we're going to put the vote for this week's episode into the post tab on YouTube. So while you're watching this, that vote is there as well. Hopefully the algorithm will show it to you, but if it doesn't, make sure you subscribe to the channel, click on the notifications bell, and then go into the post tab and vote for a bunch of our stories. And then from that point, the algorithm will get the message and show it to you on a regular basis. One of the missions that I am most excited about is Plato. And this is a planet hunting mission from the European Space Agency. It's made up of 26 separate cameras, which will continuously monitor a chunk of the sky, looking at 150,000 stars at the same time, waiting to see any planetary transits in front of those stars. Very similar to what was done with the Kepler mission, what's done with the TESS mission, another planet hunting telescope looking for transits. And this week, the European Space Agency completed the construction of the Plato mission. They added the sun shield and the solar panels, and now the whole thing is put together. Next comes the tests. And so this is where they shake it, where they put it into a giant vacuum chamber, hit it with radiation, dramatic temperature changes, and see if it can handle the conditions of space. And then I guess put everything back together that falls off or gets irradiated. If all goes well, it should launch in December 2026. So we're still a little over a year away. And if you want to become as interested in Plato as I am, check out this interview that I did with Dr. David Brown. Now it's time for some cool videos. First up, this is probably the best space-related video that I've seen this year. This is a sequence captured by the astronaut Don Pettit when he was on board the International Space Station. And it's going to look very familiar. You see the curvature of the Earth, you can see the aurora activity above the planet, and then you can see a train of Starlinks seen from space. And Don actually answered a bunch of questions about this and noted that the brightness of these Starlinks was about the same as Jupiter, so very bright, seen from the space station at this angle. And you can see other Starlinks passing through the view as well. The next video is of the Xanthitaria region on Mars. And this is a sequence of images that were taken by the Mars Express spacecraft as it was flying over. Now, it took a bunch of images and then they merged that with topography information to be able to create this 3D flyover of this region. And the main feature that you're looking at is the 1,300 kilometer long Chulbattan Vallis. This is a long outflow channel that connects the Southern Highlands to the Northern Lowlands. And then the video ends when you're looking at the 100 kilometer across Da Vinci crater, which contains a lot of smaller craters and debris field caused by a recent collision. We've got a story about this from Matt Williams. That was a bunch of space news here on Space Bites, but if you want one more story, we've got a longer version of Space Bites that we release over on Patreon, which we call Space Bites Plus. And this week's bonus story is about how the far side of the moon is also the cold side of the moon. And I'll put a link in the show notes. It's completely free. You don't have to become a patron. You can just go watch it right now. But if you want even more space news, of course, we are reporting on dozens of stories on Universe Today by a skilled team of space science journalists. For example, how organic molecules were found in old Cassini data, when fire brought ice to Mars, and how an asteroid flew closer than the International Space Station recently. I gather up all of these stories and I write a weekly email newsletter that I send out to 70,000 of my closest friends. It's completely free. There's no ads. I write every single word, no AI. So if you want that, go to universetoday.com/newsletter to sign up. All right, those were all the stories that we had this week. I'm going to chat a bit about whether or not we're becoming a 3i Atlas channel. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Barry Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bielak, Cy Nelson, David Verbath, David Giltinan, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smits, Michael Purcell, Monzo, OneStepForAnimals.org, Paul Robach, Rankaidu, Richard Williams, Sean Sargent, Stephen Fowler Melly, Team 49, Telescopes Canada, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So when you look back at our videos here on the Universe Today channel, we definitely have a lot of videos about Comet 3i Atlas. And of course, everybody's got a lot of videos about 3i Atlas. And it was in a recent QA where someone accused us of sort of following the same clickbait 3i Atlas frenzy that the other channels are following. And, you know, whenever someone accuses me of doing something, I have to sort of sit and think and like, is that true? Is that real? And I've decided that it's not. You know, there's a lot of controversy about 3i Atlas, and there's a lot of people making a lot of videos about whether or not it's an alien spacecraft or not, or whatever. And I've been getting a lot of questions and comments and a lot of pushback and a lot of snark from people who are in the it's an alien spacecraft camp. And that's led to responses from me trying to explain the kind of mainstream scientific perspective on objects like this as a comparison to the people who are making more bombastic claims about what it is. But even if there was none of that, this is still the most interesting thing that's happened in astronomy in this year. And so no matter what it is, if it was Betelgeuse exploding, if it was the first detection of supermassive black holes colliding, if there was some ongoing astronomical event, then I would be covering it week after week after week because it's very interesting and has a lot to teach us. But I can feel myself getting bored of the is it a spacecraft or not conversation in the same way that I'm bored of having conversations about flat Earth. Like I just don't. because it's just not worth my time. And so I think we're kind of getting to this place with my boredom about that controversy. And so you're still going to see a lot of stories about Comet 3i Atlas. I'm going to be covering all the new discoveries until it leaves the view of our telescopes. But I feel like I've made the defense for the sort of more skeptical, rational, scientific approach to this. And we're just going to continue enjoying all of the science coming out of 3i Atlas from here on out. All right. We'll see you next week for the next 3i Atlas episode.